This is AP Precalculus. We're on the activity 3.0 for our AP Precalculus exam review. There are 3 questions, 1 from each unit in this curriculum. Let's see number 1. Oh, and by the way, these are all calculator questions, which means you should be averaging about 6.5 minutes for this one worksheet for these 3 problems. All right, for number 1, we have 2 equations, and we're trying to subtract the 2 equations and then find where the zeros are. Again, another name for 0, if you don't like the name 0, is you can call this an x-intercept. So where are the x-intercepts when we subtract these 2 functions? So the way I'm going to approach this problem, I'm going to set this function as y1, this function as y2. My y3 function will be my j of x, and I'll subtract y1 and y2, and then I will look for our x-intercepts on the graph. So I'm going to come back to my calculator. I'm going to type in y equal to, and I'm going to type in my 1.2 x to the power of 3, and then I'm going to add 2.5x, and then subtract 3. Okay, next equation is going to be 1.3x divided by, there's a bunch of stuff in the denominator, so make sure you use your parentheses. It's going to be x squared plus 1. And now for my y3 function, I'm going to hit alpha trace y1 minus alpha trace 2. And then that's y1 minus y2. Make sure I do the order there. Oh my goodness, I'm glad I double checked, because check this out. My h of x function is my y2. I was supposed to do y2 minus y1. Check that out. So let's come back here, and I'm going to clear this and say that this is really alpha trace y2 minus alpha trace y1. There we go. Okay, I'm not going to graph these previous 2 questions, so I'm going to hit enter over the equal to signs for each of these. And then from here, I'm going to change my window. Look at all these x-intercept possibilities. The lowest value is a negative 1.9, highest value is about 1. So let's change our window over here from, I'll change it to like negative 2, and I'll make my maximum 1. One of the options is 1, so maybe I'll change it to like 1.5 so I can actually see it. I'm going to hit zoom 0 to zoom to fit, and let's see where all of our x-intercepts are. This is taking a long time to graph, and if you're ever needing to interrupt the graph, you can always hit the on button to stop the graph. If you want it to graph faster, if you go to the window button and you change your x resolution to a larger number, like 3, for example, and then you graph it, it will graph much quicker, but it'll be slightly less accurate. All right, so I can clearly see, oh, that can go away. And then from here, I need to look at, come on, calculator, where that x-intercept is. It looks like it's going exactly through 1, but it's possible that it's 0.992. So how do I find that value over here exactly? Well, I'm going to hit second trace, and I'm going to look for a 0. So I'm going to hit 2, and then my left boundary is, I'm going to say 0, and my right boundary, I'm going to say 1.5, and my guess is about 1. And I got 0.992. I'm glad I double checked that. So this one is actually 0.992. All right, what about number 2? So we have a graph shown above, and it's geometric. Geometric meaning we multiply every single time, or divide, right? Technically, you multiply by a fraction. So I'm noticing that we are trying to find the 5th value. So the 5th value is that one right there. All of those, if you eyeball it, are going to be kind of hard to find. So it's better to look for the pattern here. So in the pattern, to get from this 16 to this 4, I am multiplying by 1/4. So if I'm multiplying by 1/4 every single step, I can simply say, okay, I guess the easiest way is just to go into the calculator and say, okay, if I second mode to quit out of this, if I have 16, I hit enter. If I just multiply that by 0.25, that's just 0.25, or 1/4, if you will, you get 4. So that's the second value, the third value, the 4th value, and the 5th value. You get 0.0625. I think that's the fastest way to find this. And I got the answer B. There is another way that you can do this by making a formula. You could actually fill into this formula and say, okay, well, the formula in here is going to be, I'm going to say, define G sub n is going to be the first value, 16, times my common ratio, which is 1/4, to the power of n minus, this was the first value. Remember, 16 is the first value. If I had chosen 4, that would have been a second value. So if I do a 4 here, this would be a 2 up here. And then I can use this formula, right? So that's a much longer way of doing that. But I can show you that I get the same answer regardless. So I'll type over here 16 times 1/4. And then that 1/4, I should put parentheses around here. So let me insert some parentheses. So if I'm going to do second delete to insert some parentheses, 1/4 to the power of, it'll be 5 minus 1. I'll just type in 5 minus 1, and I should get the same answer, 0.065. So yet another way to find number 2. All right, what about number 3? We have a function, and we're trying to find what is going on this interval between 0.8 and 3. So I can just look at that. So if I go to my y equal, let's clear out of all these things. Down, clear, down, clear, down, clear. So I'm going to come up here to my y1, and I'm going to type in 3.5 sine of 0.6x plus 1.1. That was all in the parentheses, right? Yep. Okay, and then from here, I'm going to change my window from 0.8 to 3. Let's see what happens. So 0.8 all the way down here to 3, and I'm going to hit zoom 0, so it zooms to fit. And okay, so what is going on right there? Well, I'm clearly seeing that the height over here is going down, down, down. So K is decreasing. You can say that the slopes are negative or the heights are going down. So it is clearly decreasing. It's not A, it's not B. And what about the rate of change? So the rate of change, I don't like that word. I change it out for the word slope. So what's going on with the slope? Is the slope getting bigger or is the slope getting smaller? Like if you're flying a plane, is the plane trying to crash into the ground or is the plane trying to pull up and not crash into the ground? Well, this one is clearly trying to crash into the ground. It's pointing steeper and steeper. It's more of like a rainbow, aka concave down, meaning it's decreasing versus a smiley face, which is trying to increase. So, whoa, don't know why that happened. And therefore we are decreasing as well. So this is going to be D for number 3. All right, that does conclude our worksheet for 3-Pete O for AP Pre-Calculus. Thank you for watching.